In this video, we're going to look at how to solve quadratic equations using 4 different methods. The first method we're going to look at is the completing the square, which a lot of students tend to find it difficult. How do we solve quadratic equation by completing the square? We have 5 steps that we have to follow. First thing, we have to make sure the equation is written in standard form. That is, everything should be moved to one side and the other side should be 0. Step 1. In step 1, what we want to do is we have to make sure this a value is 1, right? So if it's not 1, just divide everything by that number. Step 2, we want to take the constant number over to the other side. Step 3, we're going to add half of our b value squared to both sides. Step 4, on the left-hand side, we're going to factor. On the right side, we're going to simplify. Step 5, take the square root on both sides. Remember, on the right side, you're going to end up with a plus minus. And solve for x. Let's look at example 1 here. In example 1, you can notice here that our a value is 1. So step 1 is automatically done. Step 2 tells us to take away the constant number, which is that positive 12, over to the other side. And to do that, we subtract 12 on both ends. Now, once we do that, step number 3 says to add half of our b value. Well, b is -8. Half of that would be -4. And if I square that, I get 16. So we're going to add that to both sides. Next step, this now could be factored as a perfect square. And that's going to be x and then half of your b value. So x minus 4 to the second power. Because we'll have 2 of those to make this. And then on this side, if you combine the numbers, you get a positive 4. Next step says to take the square root on both ends. Just remember, when you take the square root, you will have a plus minus here. So we're going to end up with a plus minus the square root of 4. And then the square root and the exponent to cancel. They're inverse of one another. So you're left with x minus 4 equals positive 2 plus or minus 2. Add 4 to both ends, you get x equals 4 plus minus 2. So we have 2 answers in this case. One of them is going to be 4 plus 2, which is 6. And then the other would be 4 minus 2, which is positive 2. What happens if a was not a 1? Well, since my a value is not a 1, I have to divide everything by 2 to get the following here. Next step would be to take half of our b value, or sorry, we're going to take the constant number over to the other side first by adding half. Now we take our b value, right, divided by 2, and then square it. So this is my b value. If I divide it by 2, I get a -3/4. And if I square that, I get 9/16. So what we're going to do is we're going to add that number to both sides. And then we get the following here. If you combine that 1/2 plus 9/16, that will give you the 17/16. Now, let's factor this. How do you factor this? Well, just like what we did with the previous example, it's as long as you add that perfect square or that perfect number, half of this number is square, you're always going to end up with the variable x, same symbol. You take half of this number. Remember, our b value was -3/2. Half of that is -3/4. So that means this will factor into x minus 3/4 to the second power. And then on this end, that stays the same. And then from here, we can take the square root on both ends. This becomes plus minus. The exponent and the radical cancel out. we're left with x minus 3/4 equals plus minus the square root of 17 over 4. Now, you might be asking, how do we get the 4? Well, you basically take the square root of each number. The square root of 17 is not a perfect square, it doesn't simplify. The square root of 16 simplifies into the number 4. If we add 3/4 to both ends, you get x equals 3/4 plus minus square root of 17 over 4. Now, let's look at some other examples using different methods. In this example, we have 2x squared minus 4x, where the c value is equal to 0 in this case. I don't have the c value, so the better method to use here would be the factoring method. So whenever your c value is 0, solve that by factoring method. Takes a couple steps. So what we're going to do is we're going to factor. Well, what we're going to factor out of this is the 2x, right? They both have a 2x in common. So if I factor that out, I get 2x parentheses x minus 2 is equal to 0. And because the product of those two is equal to 0, we can apply that 0 product property and say that either the 2x is equal to 0 or x minus 2 is equal to 0. Divide both sides by 2, you get x equals 0 on that side. And then if I add 2, I get x equals positive 2 on that side. So my two solutions in this case would be 0 and 2. And in this example, the quadratic equation is given as the product of factors. So right away, we can apply that 0 product property. Just set each factor equal to 0. Subtract the 4, you get 3x equals -4. Divide by 3, x equals -4/3. Second equation, add 2 to get 2x equals 2. Divide by 2, you get x equals 1. So my two answers in this case would be -4/3 and +1. And for this example here, we have x squared minus 6x minus 16. That is, I have all the three terms. Now, if it's easy to factor, use the factoring method. If it's not easy to factor, or if it doesn't factor, you have to use the quadratic formula, or you can solve this by completing the square. Since my a value is 1, to solve this by factoring, what you have to do is find two numbers that multiply to -6, this number, and they add up to this number, right? We know numbers that multiply to -6 are -1 and +6, 1 and -6, and 2 and 3, one of them is negative, or 3 and 2, right? But then if you try to add those numbers, you will not end up with a -6, right? So this does not factor in this case. So let's say I want to solve this by the quadratic formula. I have to label my ABC. Obviously, A is 1, B is -6, and C is -6, and plug it into the quadratic formula. You get this. Negative and negative makes positive. This gives you a positive 36. And then, of course, minus 4 times 1 is 4, times -6 is -24. Simplify what's inside the radical. Of course, again, negative and negative makes positive. So this is the same thing as 36 plus 24, which makes a 60. Now, in order to simplify this, I have to find a perfect square that goes into 16. 4 goes into 60 15 times, so I can write 60 as the product of 4 and 15. Why did I do that? Well, if you take the square root of each number, the square root of 4 simplifies into the number 2. Now I can simplify. I can do 6 divided by 2 and 2 divided by 2. Well, 6 divided by 2 is 3, and the 2's cancel out, so you have the square root of 15. So the final answer here would be 3 plus -15, sorry, 3 plus square root of 15, and 3 minus the square root of 15. Those are my two solutions. So again, if you cannot factor the quadratic equation, you have two options. Option one would be to use the quadratic formula, or option two is to complete the square and solve for x. They both should give you the same answer. Step 4 is looking at this problem, our bx term is missing, right? That means the b value is 0, the whole term would be gone. So as you can see here, the a squared term is here. And of course, if I combine those two, that would be your c value. So the best way to solve this type of problem is to use the square root property. So whenever the bx term is not there, use the square root property, right? So how do we use the square root property? Well, try to isolate the x squared term. So move the constant over to the other side by adding 58. You get 7x squared equals 49. Divide both sides by 7. X squared equals 7. Now, if you take the square root on both ends, you get x equals plus or minus the square root of 7. And that is my final answer. So the solutions are positive root 7 and negative root 7. Now, once you're familiar with quadratic equations, inequalities would be you can use graphs to solve those. So let's say we want to solve the following inequality here. The first step, what we want to do here is we need to figure out the x values that would make it equal to 0, right? Solve it as if that was an equation. Now, we know how to solve a quadratic equation. This problem factors into x minus 6 and x minus 2 is equal to 0. Well, if I set each factor equal to 0 and add 6, add 2 to both ends, you get x equals 6 and x equals 2. Now, what does that tell me? Well, those are the x values that make it equal to 0. So if I were to graph the function, it would cross the x-axis at x equals 2 and at x equals 6. Well, how do we graph it? Well, it depends on your a value. If the a value is positive, then the graph is going to open upwards and crosses the x-axis at the two solutions that we came up with. So let's go ahead and graph this. So we have our x and y axis. I'm going to plot the numbers, positive 2 and positive 6. Since my a value is bigger than 0, since it's positive, the graph is going to open upwards and it passes through this point and it goes through that 6. Now, next is, what is that inequality? Well, this is the problem that we were given. What are we trying to solve? Well, we're trying to figure out the x values that would make this less than or equal to 0. Well, what makes it equal to 0 are the points 2 and 6. Less than 0 would be whenever the graph is below the x-axis. So what x values would give you a negative y values, basically? Well, the x values between 2 and 6, if you notice here, will have a corresponding y value down here. Remember, as you go down the y-axis, your y values is negative. So that means this will always be true. If it's less than 0, you're trying to find the x values that would give you a negative y values. So basically, wherever the graph is below the x-axis. Now, as you can see here, this area is where the graph is below the x-axis, and it goes from 2 all the way to 6. It only works for the numbers 2 all the way to 6. So that means x squared minus 8x plus 12 is going to be less than or equal to 0 whenever the graph is below the x-axis, right? This is my x-axis. The graph is below the x-axis from 2 to 6. So the graph is below the x-axis from 2 to 6, and therefore the solution to the inequality would be from 2 to 6. This is how you write the solution in interval notation. Now, are 2 and 6 part of the solution? Well, depends on that inequality symbol right here. If you do have that line underneath, that means where is this function equal to 0? In the previous step, we figured out what those x value were. They were 2 and 6, so that means 2 and 6 are part of the solution. And therefore, we use bracket around those 2 and 6. If that line underneath the less than symbol, if this wasn't there, then I would use open parentheses here. Another way to write the solution would be where x is in the middle, less than or equal to 6, and greater than or equal to the number 2. Let's look at a second example. We're going to follow the same steps. So first thing is first, we're going to change that into an equal sign to make it an equation and figure out the x values that would make it equal to 0. So we can go ahead and use the quadratic formula. That's my b value. So the negative of that plus or minus b squared minus 4ac over 2a. And if I go ahead and simplify this, I get this. And then, of course, negative 6 plus 2 is negative 4, and negative 4 divided by negative 16 is negative 1/4. We can do the same thing. Negative 6 minus 2 is negative 8. Negative 8 divided by negative 16 is positive 1/2. So the two x values that would make this equal to 0 are 1/2 and 1/4. Step 2 says to sketch the graph. So my a value, if you notice here, is negative. So that tells me that the graph is going to open downwards. And it's going to cross the x-axis at 1/2 and 1/4. So let's go ahead and sketch it. Those are the two x values that would make it equal to 0. And since my a is less than 0, it's going to open downwards. And what am I trying to solve? Well, we're trying to figure out where the function is less than 0. Where, remember, less than 0 means whenever the graph is below the x-axis. So if I were to make a box right here, the graph would be below the x-axis to the left of that number and to the right of that number. Any x value that you come up here would have a corresponding negative y value here, and the same thing here. If I pick an x value here, it will have a negative y value somewhere down here. And therefore, the area that we're looking at is this end, to the right of 1/4 and to the left of 1/2. Well, how do we write the solution? Well, the solution would be written from 1/4 all the way to infinity, because we're going to the right, and then negative infinity all the way to 1/2. 1/2 and 1/4 are part of the solution, right? Because we do have the line underneath. So that means we're going to have a bracket around those two. Infinity and negative infinity. Since you cannot reach those numbers, you cannot have a bracket at the end. It should always be a parentheses on that end.